geobyte.
Try to read this problem. It is asking like this. The length of a wire becomes L1 and L2 when 100 newtons and 120 newtons tensions are applied respectively if the condition given is 10 L2 equal to 11 L1. From this I can write that L2 equal to 11 by 10 L1 or L2 equal to 1.1 L1. Then the natural length of the wire will be L1 by natural length. Let the natural length is L naught equal to L1 by X. Then what is the value of X? X is how much? Okay. For that, let us take the body. Let us take the original body without applying the force. This may be the original length of the body L naught without applying the force. When the force F1 is applied, when the force F1 is applied, this is the length with F1 force given 100 newtons. When 120 newtons force is applied, definitely the length will be increasing at larger rate. When F2 equal to 120 newtons, the length is L2. So this is the 1 minute. This is the L1. This is the L1. Then what is the increase in length? Increase in length is L1 minus L naught. The same way, increase in length of the second case, L2 minus L naught. Okay, understood clearly? Yes. Then, as you know, change in length delta L equal to F L by A Y. From that, F equal to F equal to F equal to A Y by L into delta L into delta L. F equal to, A area of cross section remains same, Y remains same, L is original length. That original length is L naught, that is remaining constant. This AY by L original length I am writing as a constant K. This I can take L naught. Okay, this K constant K into delta L. Delta L. For for force F equal to 100 newtons, delta L is L1 minus L naught. Next, for force F2 is equal to 120 newtons. Delta L equal to L2 minus L naught. Okay. Having that information, you know, F1 equal to, let this delta L1, delta L2, K into delta L1 and F2 equal to K into delta L2. F2 by F1 equal to K delta L2 by K delta L1. K is cancelling. Then F2 by F1 equal to delta L2 by delta L1. F2 is 120 by 100 equal to delta L2. L2 minus L naught divided by L1 minus L naught. It is 1.2 equal to L2 minus L naught divided by L1 minus L naught. Okay, that can be also written as 1.2 L1 minus 1.2 L naught is equal to L2 minus L naught. But it is given L2 equal to 1.1 L1. 1.2 L1 minus 1.2, otherwise, एक minute. It can be written as 1.2 L1 minus L2 equal to 1.2 L naught minus L naught. 1.2 L1 minus L2. Look at the L2. L2 equal to 1.1 L1. 1.1 L1 equal to 0.2 L naught. 0.1 L1 equal to 0.2 L naught. Then it is given the L naught in terms of L1. So L naught equal to L1 0.1 L1 by 0.2. It is equal to L1 by 2. So it is given as L1 by X. Therefore, X equal to 2. X equal to 2. X value is, got that point? Yes. Similarly, look at the another important problem. Look at this problem. Young's moduli of the material of wire A and wire B are in the ratio. That means Young's modulus of the A by Young's modulus of the B is given 1 by 4. While its area of cross sections are in the ratio, area of cross section of the A by area of cross section of the B is given 1 by 3. If the same amount of load is applied for both wires, it means FA equal to FB. The amount of elongation produced in the wire A and wire B in the ratio of, that means delta LA by delta LB is how much? That is the problem. As you know, delta L equal to FL by uh, AY. Okay, it is asking Young's modulus of the material in the ratio while the cross section. If the same amount of load is applied for both wires, the amount of elongation produced in the wire A and wire B in the ratio. That means L remains same. Here L is not given from this, right? So delta LA, otherwise, okay, options are given. 1 minute. Options are given. Okay, so let us write once again data. Young's modulus of the material of wires A and B are in the ratio YA by YB given 1 by 4, while its area of cross sections are in the ratio AA by AB equal to 1 by 3. If the same amount of load is applied for both wires, that means FA equal to FB. The amount of elongation produced in the wire A and B will be in the ratio of, that means delta L for A divided by delta L for B is how much? Okay. For that, as you know, delta L equal to FL by AY. Then delta L for A equal to FA LA by AA YA. Similarly, delta L for B equal to FB LB by AB into YB. Change in length of the wire A divided by change in length of the wire B equal to FA LA by AA YA, right, into, directly I'm writing AB into YB by FB into LB. Here length is not given. Let LA equal to LB. Given that FA equal to FB. Here FA equal to FB, LA equal to LB. Finally it is AB by AA into YB by YA. What is the AA by AB? AA by AB is 1 by 3. Then AB by AA 3 into YB by YA. YA by YB 1 by 4. YB by 1A, YA 4. It is equal to 12. That is the answer. Look at the options. 12 is to 1. Option A itself is absolutely correct. Understood clearly? It is looking lengthy but very easy problem. Understood? Yes. Then let us take the another important problem. Look at this problem. Two wires, each of radius 0.2 centimeters. Radius of the wire are equal to zero point 0.2 centimeters. It is equal to 0.2 divided by 100 meters. And negligible mass. Wire mass is negligible. One made of a steel and other made of brass. This is the steel wire and this is the brass wire. Okay. Next are loaded shown in figure. Right. This is the right 2 kg. This is the 1.14 kg. Let this is the M1 and this is the M2. Okay. Then the elongation of the steel wire is equal to dash times the 10 power minus 6 meters. So this dash you need to fill. Young's modulus of the steel. Let me write it clearly. Young's modulus of the steel. Y for steel equal to 2 into 10 power 11. And G value given 10 meter per second square. Okay. Then you need to decide the force on the steel. Tension on the steel wire. T equal to M1 plus M2 into G. M1 is 2 plus M2 1.14 into G10. 3.14 into 10. It is 31.4 newtons. That is the force. Then change in length of the steel equal to force on the steel, L of the steel by A of the steel multiplied by Y of the steel. F of the steel is nothing but tension only 31.4 newtons into length of the steel. Look at the length of the steel 1.6 meters. A of the steel equal to pi r square, pi into r value for steel. Okay, of course, both are maintaining the same radius, 0.2 by 100 meters. 0.2 square by 100 squares. Pi into 0.2 square divided by 10 power 4. So pi into 0.2 whole square divided by 10 power 4 into Young's modulus of the steel is Young's modulus of the steel 2 into 10 power 11. 2 into 10 power 11. Simplify this value. 31.4 into 1.6 6 into 10 power 4 divided by pi into zero point 0.2 into zero point 0.2 into 2 into 10 power 11. So it can be also written as 314 into 1.116 into 10 square divided by 5 into 2 into 2 into 2 into 10 power 9. Simplify this value. It is equal to, right? It is equal to, simplify this value for getting the answer. So it is, 314 into 16. Okay. So pi value equal to what? Pi equal to 3.14 na. So 3.14, this is 100 times 100. It is 1600 into 10 square divided by 8 into 10 power 9. 8 200. It is 2 into 10 power 4 by 10 power 9. It is equal to 2 into 10 power minus 5 meter square. It is equal to 2 into 10 power minus 5 into 10 power 6 mm square. That is equal to 20 mm square. That is equal to 20 mm square. So anyhow, area equal to 20 mm square. Look at the options, right? So here it is asking meter square only. Area, elongation, 1 minute. Elongation in, this is elongation, na? This is elongation, not in meter square. So 1 minute. 2 in 10 power minus 5. But it is asking 10 power minus 6, na? So it is equal to, you should be very careful, 20 into 10 power minus 6 meter. 20 into 10 power minus 6. Here it is 20. Got that point? I thought it is area. It is elongation only. Change in length. Okay? Understood clearly? Yes. Similarly, let us take another problem. Look at this problem. It is asking like this. An aluminium rod with Young's modulus y equal to 7 into 10 power 10 undergoes elastic strain. Change in length by original length is 0.04 divided by 100. The energy per unit volume stored in the rod is, energy per means strain energy. Energy per unit volume equal to half into stress into strain. Stress into strain. But as you know, Young's modulus equal to stress by strain. Stress by strain. From this, I can write that stress equal to Young's modulus times strain. So it is equal to half into stress equal to Young's modulus times the strain. Strain multiplied by strain square. You know delta L by L. This itself is the strain. Change in length by original length. Half into Young's modulus. 7 into 10 power 10 multiplied by strain. 0.04 whole square divided by 100 square is equal to half into 7 into 10 power 10 0.04 into 0.04 divided by 10 power 4. Let us take another slide. Strain energy per unit volume equal to half into 7 into 10 power 10. 7 into 10 power 10 into 0.04 into 0.04. 0.04 into 0.04 divided by 10 power 4. 10 power 4. It is half into 7 into 7 into 100 into 100 into 4. 10 power 6 into 0.04 into 0.04 divided by 10 power 4. It is equal to half into 7 into 100 into this 100 into 0.04. 4 into again 100 into 0.04. 4 into 10 power 2. 10 power 2. It is 2 2 times 14. 14 into 4. 56. 5600 is the energy per unit volume. That is the answer. 5600. Look at the option C. Option C is absolutely correct. Understood clearly? Yes.
Geobyte.